Managing project scope is one of the most important and crucial tasks that a project manager has, and we will put quite a lot of emphasis on scope management and scope definition throughout this unit. What is scope? Scope refers to all of the work involved in creating the products of the project and the processes which are used to create them. Scope management includes the processes involved in defining and controlling what is or is not included in the project. Very important that you clearly articulate what is not included. The project team and stakeholders must have the same understanding of what products will be produced as a result of a project and what processes will be used in producing them. The Bradley video shows what happens when scope is not controlled. The project size, complexity, importance, and other factors will affect how much effort is spent on scope planning. Two outputs from the scope is scope management plan and the requirements management plan. The scope management plan is compulsory, really, for large or highly technical projects. It includes how to prepare a detailed project scope statement, how to create, maintain, approve the work breakdown structure, how to obtain formal acceptance of the deliverables, how to control requests for change. The requirements management plan is about planning, tracking and reporting requirement activities, performing configuration management, prioritizing requirements, not all requirements are equal, and how to trace and capture the attributes of requirements. So defining the scope should include a product scope definition, a user acceptance criteria, detailed information on all project deliverables. It may also include boundaries, constraints, assumptions, references to supporting documents, functional and design specs. Having a good scope helps improve the accuracy of time, cost, and resource estimates. It defines a baseline for performance measurement and project control, and it aids in communicating clear work responsibility. The project team must develop clear documentation of the project's products and procedures. They need to inspect, verify, and evaluate with users, sponsors, and stakeholders that this is what's intended, and sign off by the customers to formally accept the project deliverables. I have another short video, so we'll watch this about a ship construction.
The Vasa and Scope Creep, based on a true story. 400 years ago, the King of Sweden, Gustav II, was at war with Poland. The war had been raging since 1618, and the King's plans required a strong presence in the Baltic Sea. Most of the ships in the Swedish Navy were small patrol vessels with few guns. The King urgently needed to strengthen his fleet, so he decided to build larger, heavily armed ships. And to lead this project, he hired master shipbuilder Henrik Hibbertsson, tasking him to build a gunship 108 feet long with 32 cannons on the gun deck. Master Henrik had built several ships with those specifications, so he accepted the commission and estimated that the ship would be ready for war within 2 years. However, something seemed wrong. Despite the urgency of the project, the King kept requesting design changes. Eventually, after several twists and turns, the King approved the final design of the ship, which was to be called the Vasa, and he donated the raw material to begin construction, a forest of 1,000 oaks. A few months later, tragedy struck. The Swedish Navy lost 10 ships during a heavy storm, so the King called Master Henrik with a new instruction. Accelerate the project to finish sooner, and don't worry about the budget. Henrik adjusted the plan and resources to accelerate the project, but a few months later, another message arrived from the King. Dear Henrik, I've been thinking. In addition to speeding up the project, you must make the ship bigger, at least 120 feet long, so it can carry more military cargo. Well, this made things complicated for Henrik because he had no previous experience of building bigger ships, and at that time there were no mathematical simulators to automatically enlarge the design. He'd also already cut up all the timber to the original size. Henrik convinced the king that if he wanted to meet the accelerated end date, the maximum size would have to be just 111 feet. Even though the king was not very satisfied, he approved the new project scope. Henrik and his team were happy because they finished the 111-foot keel in record time. However, his beloved king appeared with another new requirement. In Denmark they're building a larger ship and it has a double row of guns, and I want ours to be like that. Henrik was desperate. The king was asking for something that seemed to be against the laws of physics, and he had no materials, no blueprints, no specifications, no experience in building such vessels, and no time. Henrik told the king that in order to enlarge the Vasa, they would have to use wood that was reserved for another ship. The king approved the change, and Henrik agreed to enlarge the ship to 135 feet. But it would probably have been simpler to cut down a new forest instead of stealing resources from another project. The construction team had grown considerably, and by this time more than 400 people were working on what was then the biggest project in the history of Sweden. When they had made good progress with the expansion of the Vasa to 135 feet, the king had another word with Henrik. One more thing I forgot to mention. Instead of 32 cannons in one row, we need to fit 36 cannons in 2 rows, plus another 12 small cannons and 48 mortars and 10 other smaller caliber weapons. Henrik was really stressed with all of these changes on the fly when they had no time, but he understood that his king must always be obeyed. Fortunately, the budget wasn't a limitation, so Henrik replanned to accommodate all the new requirements. After several months of work and close to the deadline, the project had made really good progress. However, the king interfered again. Henrik, I'm very pleased with progress, but instead of 36 large and 12 small cannons, we need to have 64 big cannons so we can use the same ammunition for all the guns. The king obviously didn't understand that having 64 big cannons would add so much weight that the Vasa would become unstable. Unfortunately, Henrik was not able to tell the king about this because he died of a heart attack when he heard the new requirement. Fortunately, Henrik had a skilled assistant, Hein Jakobsen, who took over the project, determined to please his beloved King Gustav. Hein moved forward with the project, including the new requirement to include 64 big cannons. Costs were skyrocketing, and the king continued to push for an accelerated end date. The project was almost ready when the king sent for Hein. I've been looking at those ships the Danish are building. Our ship has to look better than theirs, so I want you to add some decorative sculptures. About 700 should do it. That'll show those Danes. During all his years building ships, Hein had learned 2 things. A king must always be pleased, and size matters. The short time remaining to the end of the project was spent adding decorative sculptures that had no connection with the military equipment, rather than investing that precious time in structural testing of the stability of the ship. Remember all that extra weight from the cannons? Hein insisted that the Vasa couldn't sail without completing a stability test. But there wasn't time for a full test, so they just told 30 Marines to run from one end of the ship to the other. Even with this simple test, it became clear immediately that the ship wasn't really stable. But the king couldn't wait any longer and threatened that someone could get hurt if they didn't finish everything right now. So no one tried to improve stability, but then Hein didn't know how to do that anyway. Finally, after 2.5 years of construction, the big day arrived. The most modern, sumptuous and largest ship in the Swedish Navy was ready to sail. And on the 10th of August 1628, amidst great celebrations with fireworks and in the presence of several foreign diplomats, the Vasa left the port of Stockholm with 150 passengers under Captain Surfring Hansen. As the ship sailed away, the gun ports were opened and the guns were pointing out so that they could fire a salute to the dignitaries on shore. Suddenly, a gust of wind swelled the sails and tilted the ship to one side, and the first row of cannons hit the water, and the water began to enter through the open gun ports. The crew tried desperately to save the ship, but they couldn't stop the catastrophe. Water rushed onto the gun deck and down into the hold, and in just 15 minutes the Vasa had sunk completely, killing 53 crew only 120 metres from shore. The most expensive ship in Swedish history had only sailed 1,300 metres. Who was to blame? Obviously it must be the captain. Next day Captain Hansen was arrested and an inquest was called. Fortunately, justice was done, and the official verdict of the inquest on the reason for the sinking of the Vasa was, "Only God knows." Of course, Master Henrik could have told them the real reasons, but then he was dead and buried. So what can we learn from the tragic story of the Vasa? The pressure of a tight deadline combined with constant requirement changes, lack of technical specifications and the need for innovation, these things can kill any project. So even if your project has a powerful sponsor who insists on changing the scope, be very careful about gold plating your requirements. Scope creep can be fatal.
An amusing story, no doubt, but this is what happens on so many projects. It's urgent. It has to be done. We have to add these things. And this is largely driven by the notion that a project has a defined end. This is less and less true today. It's certainly not true with digital technologies. The projects don't have a defined end. They will go on forever. And so it's really not an acceptable business model to add features constantly to technology projects. So let's have a look at how to complete a work breakdown structure moving forward. So we're going to break the tasks down into identifiable components: the scope, the work breakdown structure, and the sequencing. The product breakdown ensures that all required products for a project are considered during the planning process, and development of the project proposal or project charter is consistent with understanding of what's required to be delivered to meet the business needs. There are often dependencies between products, work products. One cannot be started before the completion of another. Hardware has to be delivered before the system is up and running. Yeah, simple things. There will be time when the lower levels of a product breakdown structure cannot be completed as there is uncertainty about the components. And this is where a plan-based project, waterfall project, starts to become extremely challenged. You don't necessarily know the detail right down to the nth degree, and you can't know until you're involved in it. A work breakdown structure is a deliverable-oriented grouping of the work involved in a project that defines its total scope. It's the work that needs to be done in certain sequences to deliver outcomes. We want to deliver this in logical parts, and we want to start with those foundational components of work that everything else depends upon. The top-down approach, you start with the largest items of the project, break them down into subordinate items. Bottom-up, you would start with as many specific tasks as possible and aggregate and organize them. There are many tools for doing this. Mind mapping is one that's been used very successfully in coming up with a work breakdown structure, identifying what components of the overall product belong together, which ones add up to being delivered as a program of work. So how does Agile go about doing this? And we have another short video to look into the approach that Agile takes.
Hi, I'm Mark. I help organizations write software more efficiently. A big part of this is helping teams find ways to organize their work in a way that follows Agile values and principles. In this video, we're going to talk about creating user stories. User stories aren't Agile in and of themselves, but they can be used to help us follow Agile principles. For example, here are 3 Agile principles that we should keep in mind for this video. Working software is the primary measure of progress. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Simplicity, the art of maximizing the amount of work not done, is essential. If working software is the primary measure of progress, we need to make sure we organize and track our work in a way that supports this goal. We need to make sure that our work is organized and chunked into units that represent value to the customer, and we need a way to sort out what is extremely valuable from what is less important. Most teams find that the best way to achieve these things is to visualize their work so it's easy to see what has been done, what is being done, and what is yet to be done. Visualizing the state of various pieces of work can be done in software or even on a wall with sticky notes, but in this video, we want to concentrate just on how to represent the units of work. A good approach is to represent the work through simple stories that describe what the user's world must look like in order to mark a story as complete. Here are some example stories using a typical story template. As a registered user, I want to change my password so I can keep my account secure. As a website visitor, I want to subscribe to the mailing list for a product so I can get product updates through email. As an admin user, I want to disable a user so I can prevent unauthorized logins by past employees. As a mobile app user, I want to save all my data to the cloud so I can access it from another device. There isn't anything magical about this particular format for stories. The examples we've just seen cover who, what, and why. Having a template is a good way to make sure you capture enough information to represent the idea of what the user needs without getting bogged down in all the implementation details. When our development efforts are driven by stories that represent our understanding of user needs, it supports our principles and fosters good development practices. Stories that are written in ways that violate our principles will hinder good development practices. Anything we can do to increase the quality of our stories will make the rest of our development process more efficient. One time, I was working with a team that was just starting to organize their work like this, and we were using a template similar to the one we've just seen. One of the users had missed the initial meeting where we explained what we were trying to do. He was a bit confused and asked why he kept seeing all these short pieces of poetry about software. Evidently, he thought we were writing some strange form of haiku. Good stories start off as fiction. The setting is the world in which the user interacts with the software. The story is written from the user's point of view and talks about things from the perspective of the user. The user perspective is very important because our principles say that we are going to define our progress based on giving the user the ability to do something valuable with the software that they were not able to do before. If we are working on stories that aren't creating business value for the customer, we are doing work that we've explicitly said isn't going to count as progress. So how do we handle all the work we need to do that the user can't see? How do we handle stories about the developer's world? How do we handle stories like this? As a developer, I want a database with all the tables to model the data so I can store information the application needs. This is a bad story because it violates our principles for software development. Notice I said the story is bad, not the idea of having a database to store data. We definitely need a database. But if we create this story, almost all of the application depends on it being done first. We could complete this story and have no functionality we can show our user, nothing they can actually use as working software. But this would violate our principles. Further, the information we need to acquire to complete this story will only be known when we've figured out how we are going to build the other parts of the system. So in effect, a story like this is both a prerequisite for and a dependency of every other story. When you have two things that both depend on the other being done first, you have a recipe for deadlock. If you've ever worked on a story like this, you may have experienced a long period of time where the user is asking how things are going, and the development team is saying, well, we have a bunch of setup work to do first before we can start working on the actual application. There is another way. If you write your stories from the user perspective, you can build just the parts you need in order to create some value for the user. This likely will mean building some of the database, but only the pieces you need as you need them to complete each story. It may seem counterintuitive for developers to build software from the user's perspective, because such an approach means you may have to rework some of the things you've done in the past as future stories become clear. However, software projects that fail usually do so because they weren't focused on delivering actual usable business value to the user on a regular basis. Building the application the way the user thinks about value minimizes this risk. If you are following the other Agile principles, the cost of some rework is trivial compared to the benefits it provides in delivering business value sooner rather than later.
So that's the Agile approach to defining scope, using stories. It's very powerful. And it could apply both in terms of Agile and waterfall planned projects. So time management. There are 6 processes in time management. Planning the schedule management, defining the activities, sequencing the activities, estimating activity durations, developing the schedule, and controlling the schedule. And these apply whether you're doing waterfall or Agile. Planning schedule management involves determining the policies, procedures, and documentation that will be used for planning, executing, and controlling the project schedule. Scheduling, the methodologies, tools, level of accuracy, user measure, control thresholds need to be determined. How accurate do you need to be for planning purposes? It can never be perfect. What do you need to know? Agile has a whole methodology around how accurate you need to be or don't need to be. Network diagrams are a technique for showing activity sequencing. A schematic displays of the relationships among or the sequencing of activities. And there are various formats: activity on arrow, or the arrow diagramming method, or precedence diagramming method. The precedence diagramming method is the most common. Activities are represented by boxes. It's very useful for visualizing the time relationships and dependencies, and it shows the relationship between activities. It's more popular than arrow diagramming, and it's used by most project management software. And this is pretty much what it looks like. We start with A feeds into B, and A is D has a dependency on A being finished. E and F can't commence until B has started, and so on. All right, that's all for this unit. I'll see you on the next video.